Optics clustering. Algorithm optics ordering points to identify the clustering structure. Pseudocode steps. 1. Data preprocessing. Description: prepare the data for clustering by handling missing values, encoding categorical variables, and scaling numerical features. Steps. Handle missing values imputation. Details: replace missing values using mean, median, or interpolation methods. Encode categorical variables if necessary. One-hot encoding. Label encoding. Details: convert categorical variables into numerical format suitable for clustering algorithms. Scale numerical features: standardization or normalization. Details: standardize features to have zero mean and unit variance or normalize them to a fixed range. 2. Model training and clustering. Description: train the optics model using the preprocessed data. Steps. Set parameters. Details. Set the minimum number of points in a cluster min samples. Set the reachability distance apes for defining the neighborhood of a point. Build the reachability plot. Details. Compute the reachability distance for each point based on its neighbors. Construct the reachability plot to identify clusters and noise points. 3. Evaluation and validation. Description: evaluate the clustering results using various metrics and techniques. Steps. Evaluate clustering quality using metrics like silhouette score, adjusted Rand index, or Davies-Bouldin index. Details. Silhouette score measures how similar a point is to its own cluster compared to other clusters. Higher values indicate well-defined clusters. Adjusted Rand index measures the similarity between two clusterings, correcting for chance. Davies-Bouldin index measures the average similarity between clusters, with lower values indicating better clustering. Handle noise and outlier detection through cluster analysis or outlier detection methods. Details: identify and manage noise and outliers using techniques suitable for optics clustering. Assess cluster stability and robustness. Details: monitor how clusters change over time and evaluate results across different datasets to ensure consistency. 4. Handling categorical variables. Description: process categorical variables appropriately for clustering. Steps. Encode categorical variables using suitable techniques. One-hot encoding. Label encoding. Details. One-hot encoding: convert categorical variables to binary vectors. Label encoding: assign a unique integer to each category. 5. Fine-tuning and optimization. Description: optimize model parameters and settings for better performance. Steps. Optimize min samples and apes parameters based on evaluation metrics and domain knowledge. Details. Experiment with different values of min samples and apes to find the optimal clustering structure. Adjust coordistance calculation methods. Details: modify coordistance calculation methods to improve the separation of clusters and noise points. 6. Handling uncertainty and drifts. Description: manage uncertainty and detect concept drift in the clustering process. Steps. Monitor cluster stability over time to detect concept drift. Details: use statistical tests or monitoring systems to detect changes in data distribution. Implement reclustering strategies or update clustering parameters based on drift detection. Details: adjust clustering parameters or retrain the model when significant concept drift is detected. 7. Test case criteria. Description: define test cases to validate and assess clustering results. Steps. Define test cases to validate clustering results against known ground truth or domain knowledge. Details: select datasets with known cluster structures and validate the clustering results. Evaluate clustering robustness across different datasets or subsets. Details: test the algorithm's performance on diverse datasets to ensure its generalizability and Robustness. Evaluation metric. Description metrics to evaluate the quality and performance of clustering. Metrics. Silhouette score. Details measures how similar a point is to its own cluster compared to other clusters. Higher values indicate better defined clusters. Adjusted RAND index. Details measure similarity between two clusterings. Correcting for chance. Values range from -1 to 1, with 1 indicating perfect agreement. Davies-Bouldin index. Details evaluates the average similarity between clusters. Lower values indicate better clustering quality.